Meanwhile, how is the week 3?
Easy, sir.
Easy, sir. It's great.
Easy for everyone? Are you able to understand the concept and all?
Yeah, yeah.
Yes, sir, it's easy, not a big deal.
So the lecture videos are itself complete.
Okay, okay, okay. So what should we do today? I mean, is the problem, I mean, want to ask problem, or should we summarize the concept first and then take the problem?
Summarize the
Let us
concept first,
do
sir.
concept.
Summarize first.
Yes, sir. Summarize the concept first, sir.
Yes, sir.
Okay, okay. So what we'll do, we'll try to cover all the concepts of week 3. Okay. After that,
Okay, sir.
if we have time, then we'll discuss the concept. Okay.
Okay, sir. Thank you, sir.
Okay. Okay. Just wait for 2 to 3 minutes so that
So can you explain
Okay, sir.
percentile concept?
I will explain all the concept. I will go week wise. I mean lecture wise. Okay.
Okay, so because I had doubt in that.
Okay. No, no problem. No problem. We'll discuss. We'll discuss. We'll try to discuss all. Okay. Also, mock has been released. I hope you guys get the notification and all.
Yes,
I've
sir.
already finished that weekly mock
Yes,
test,
sir.
sir.
Done.
Okay, great, great, great. Hi, Devansu, you can attend. So I will cover all the concept. Okay. And,
Mock tests marks will also be included in qualifier or
mock is just an idea for the qualifier.
okay.
So far we have released week 1 and week 2. Once syllabus of week 4 will be finished, so we'll release one mock which will include the syllabus of week 1 to week 4. I mean all week first 4 weeks. Okay. So you will get some sort of idea to for the qualifier exam and all. Okay. Okay. So let me start the. Let me share my screen.
Sir, can you explain also how to fill EMQ graded assignment or like practice assignment?
How to? Hello. Can you repeat? I did not get your point. Hello. It's also summarizing the concept. Okay, can you repeat? Okay, so let me start. You are not saying anything. Okay, so far till week 2, we studied about categorical data, right? Correct?
Yes, sir.
Yes,
Okay.
sir.
So in week 3, we'll discuss more about week 3 onwards about numerical data. Okay, so basically, we had what we had. Okay, so what are the types of data? Categorical and numerical, right?
The two types are categorical and numerical.
Categorical and numerical. Okay. And there are two types for the numerical. What are those?
Discrete and continuous.
Discrete continuous.
and continuous.
Correct. So these two are clear, discrete and continuous.
Yes, sir.
Correct. Now let's study further. So see, discrete is what? Discrete data or discrete variable is what? Which involves the counting of something, right?
Yes, sir.
But continuous is something which involves the measurement. Not
Measurement.
we cannot count, right? That's something discrete and continuous. So in week 3, if you see, we'll discuss about histogram, right?
Yes, sir.
So you know how we can represent the histogram. So there are some terms in histogram: lower class limit, upper class limit, class width, okay, class mark and all. So what is the class mark? Anybody?
Average
Average of the upper and lower class
limit.
limit.
Yeah, suppose this is
Range
The
of
the
the
average of
this
upper
is
and lower
one
limit.
one interval of the uh like one interval of your x-axis, right? Like that. It can be a comma b, c can d, c comma d and all. So this is the lower limit of the class, correct?
Yes, sir.
This called the upper limit, correct? And what is the class mark?
A plus B by 2.
A plus b by 2, right? This is the something which is called the class mark. And histogram, how I can represent histogram? Continuous rectangles, right? I can say diagram of the continuous rectangle. Like this is, suppose this is 0, 10, 20 and all. So let's say
Sir, you're not audible, sir.
I'm not audible. Hello,
You're audible, sir.
audible, right? Yeah. So can you check your mic? So it's a continuous histogram, right? Like this, 10 to 20, then 20 to 30 and all. Whatever you have defined your class interval accordingly. Okay. Another thing is, if you are familiar with the stem and leaf plot, right?
Yes,
What
sir.
is this? So stem and leaf plot is nothing but basically what we are doing in stem and leaf plot. We are doing like each observation. We are separating each observation in two parts, right? So in two parts means one part is called the stem and one part is called the leaf. Okay. So there will be key provided to you. Key means suppose I can do like I can say like 7 slash 5. So this is for the stem. Suppose I'm saying 7, 5. So this means 75. Correct? See, for every time stem and leaf plot, I will provide the I will miss there will be provided like what is the meaning of like see let's take another example. Suppose I'm saying I can suppose I want to define the 75, 78, right? How I can do?
7,
When is stem
8,
and
and
5
5
comma
and
8 is
10.
5
leaf.
comma 8, right? Right? This is something. So also you can keep in your mind stem and leaf plot. Observations of the stem and leaf plot is already in ordered way, right?
Ascending order.
Yeah, in ascending order. Is that like that or not?
Yes, sir.
Correct?
Yes.
Suppose I want to so suppose I can make like 6 comma 0, then 61, 62 like that. Correct?
Yes.
Yes, sir.
Okay. So
Sir, actually, I had a question. Do we
mhm.
have to put an order on the stem also?
Yes, then it will be ordered way, right? If you will not put order in stem, suppose this 5, correct? If you are putting 0, then observations you will have 60, 61, 62, 50. Is this in ordered way? Ascending order? No, right?
Okay, sir.
Clear? Okay. Similarly. Okay, so this is just some rough idea about this too. Is this clear? So we can move to the idea of like descriptive measures and all.
Yes.
Sir, if a number
Sir.
is repeated in leaf twice, then the observation will be 2.
Yes, we have. So I have to write like this. So it means 62, comma 62.
Okay.
Sir, it maintains order.
Yeah,
Means in this case, we have to write 50 first.
yeah, 50 first. Yeah. Then
Okay,
it our observation will be in ascending order.
Okay, sir.
Okay. And one more important thing, suppose I have written like this 51, and let's say 6, 2, 3, 5, and let's say I have written something, let's say 8, 9, then 8, 0. So can you tell me what is the meaning of this particular part? Anybody?
So 7 has no
70.
value, sir.
So can I say it's a 70?
No, sir.
No, sir.
No, we
Yeah.
can't say. Observations are
It's
There
a
is no
single
observation.
digit.
So we
There
have
is
to skip 7.
correct. There is no observation for this particular stem. So keep this in mind, because sometimes people make mistake. They consider it as 70. But what is the fact here? There is no observation from 70 to 79 here. Last observation is 69, then its next observation is 80. There is no observation from 70 to 79. Clear?
Yes.
Sir,
I
if there
hope.
was something like a 7 straight stem,
Hmm?
then there will be after 69, no 70 to 79, only 80 after 69.
Can you repeat? Can you repeat?
Sir, in that example,
Huh?
you said 7 is there as the stem,
Huh?
and after the line, there is no number.
Yeah, that
So
means
that,
there is no observation from 70 to 79.
how is that, sir?
Okay. So what is the meaning of this one? I told initially 7 stem 5 means I'm providing a key. This means 75, right?
Yes, sir.
Then I'm putting a stem and no observation in leaf. So that means there is no observation. Okay.
It's just
If
7.
you yeah, which nothing. It's not 7. So see, while you will draw a stem and leaf plot, always
sir.
key will be provided. Suppose I provided like 7. Let's say I'm saying 2 comma 1 is 21,
Yes, sir.
right? So that means always the observation should be like this. Suppose I'm saying 7 and not comma slash 0, that means 70, right?
Yes,
But
sir.
there is still 0 is not there, right? So that means there
Yes,
is
sir.
no observation. It's a simple.
Yes, sir.
Okay.
Okay, sir.
Okay. Great. Okay. So next is I think a measure of
Excuse me,
sample.
sir.
Yes.
I have a doubt related to this topic only, that I come across a question in which it was asking to find the mode of the stem and leaf diagram.
Okay.
But how to do that, I don't know.
Where is that?
It's an assignment number. 1 second. Assignment number 3, week 3. Question number.
Assignment number 3
5.
means what? Activity 3.1, 3.3, what?
Activity 3.3. Question number 9.
Yeah, okay. It's asking about mod, right? So I told earlier you have to write the observations, right? Mod is what? Mod is what basically?
So the highest data, sir. In the
Highest
set.
data or the
Maximum
data
number
which
of
occurs?
occurrence.
Maximum number of
Yeah, maximum number of frequency, sir.
Yeah, so there is difference between highest data and maximum number of occurrence, right?
Okay, sir.
Yeah. So which observation is occurring more number of times here?
64,
71, 71,
71,
64.
71.
Now here you can see 64 is
and
2 times,
69.
69 is 2
69.
times, right? So 64 and 69 are the mod. Is that
And
correct?
71 also.
71.
Yeah, 71 also. That's all.
And we will consider it as multimodal, right?
Yeah. Clear?
Sir, then how to find a median of this, sir?
Okay,
Median.
median is what? Middle observation, right?
Yes, a middle observation, sir.
If it's odd,
Based on the
odd
stem
number.
and that one, sir.
See, stem is already in observations in stem and leaf plot, or already in ascending order, right? So what you have
Yes,
to
sir.
do? So you have to see if it's you have to count the number of observations, right? If it's in odd number of observations, that means middle observation will be median. If it's even, then you have to take the average of the
Average of that.
two middle observation, right? Middle most observation. So similarly, you
And
can do. There is no need to arrange the data, that data set. Okay.
Not in ascending, already is in ascending order.
It's
So
in
no need
ascending
to-
order. Yeah, that's the stem and
Yes.
leaf plot.
Yes, sir.
Okay.
Okay, sir.
And sir, you just wrote an example in which there is no values for 70. In that case, that 80 and 81 will be considered as outlier
Yes.
or what?
Sorry, 80 and 81.
are will be considered as outlier data.
No, no. What is the outlier? First of all, you tell me. What do you mean by the outlier? Okay, suppose I'm writing. Okay, that's why I told you write this separately. It means I have to write the observation like 50, 51, 62, 63, 65. Let's say 68, 69. Then I'm writing 80. So 80 and 81 is the outlier. It doesn't mean it's there is one break, so it will be outlier, right? So outlier is something which is extreme value, right? Which is not. I mean, there is a much more difference from the normal observations, right? Okay, we'll come to
So
you.
if we just take 800 instead of 80, that will considered as outlier.
Yeah, that's why I told. Let me go to one by one concept. Okay.
Okay.
I will come to outlier. Yeah, don't worry. Now that estimate lift plot is clear to you, mod and all.
Yes, sir.
Okay. Okay. So what is the meaning of measure of central tendency?
Which focuses on the
Basically will see the measures, right? What are the measures which indicate the central value of my data set, right?
yes.
Correct?
What's typical value of the data set?
Same. Central value of data set, right? So we in this course, in this week 3, we will study 3 measure of central tendency, which is called mean, median, and mod, right? So we will discuss some properties also with this mean, median, and mod. Okay. So what is the mean? Basically, anybody? Mean is the simply
Sum of all
average.
observations divided by the total number of observations.
Correct. So mean is nothing but suppose I have observations. So let's discuss the mean. Okay. First. So suppose I have observations x1, x2, so on, xn, right? So mean is defined as nothing but sum of all the observations divided by the number of observations, right? So in simple way, I can write as summation xi divided by n. Okay. Now, one more thing. Suppose, frequency is given to you. Okay. Okay. We'll come to this topic later about frequency. So I have this data set, right? Now, suppose I want to add, there are some properties for the mean, median, and mod. Suppose I want to add a constant to all the observations. Okay. Let me come to, suppose I'm considering the observations 1, 2, 3. Okay. Suppose these are the observations, right? What will be the mean of this data set? 15 by
2.5.
3.
3 is the mean, right? Now, tell me, suppose I want to add 3, a constant 3 to all the observations. Then what will be my new data set?
4, 5, 6, 7, 8.
6, 7, 8, right? Now, tell me, what will be the mean of this data set now?
30 by 10, 5, which is 6.
It will also get added to the mean.
6.
30 by 5, right?
5 is 6.
Which is 6. So if you see, if you observe, so this is same as 3 plus 3.
Yes, sir.
Yes, sir.
So one
Old mean plus
is
constant.
okay. So one mean is kind of, if you see this is right. This 3, right? Okay, and this rate
Yes,
3
sir.
is the this constant value, right?
Yes.
Yes, sir.
So can I
Sir,
say
if it is like multiply by 2 and
I will come to that point. Don't worry, don't
yes,
worry.
yes.
Let me go one by one. Okay? So can I say here, if I want to add a constant to the observation, then new mean, I mean mean of the new data set will be old mean plus that constant.
Yes.
Yes, sir.
Yes, sir.
Okay. So if I want to generalize, so suppose I have observations x1 to xn, right? And I want my new data set is like x1 plus c, x2 plus c, so on xn plus c, which is I'm denoting as, let's say I'm denoting it as y1, y2, so on yn. I mean, in short, if I'm saying yi is nothing but xi plus c, right? In general, can I say I is nothing
Yes,
but
sir.
1 to n? So my new mean will be old mean plus that constant,
Yes.
correct?
Yes.
So far it is clear for everyone.
Yes, sir.
Yes.
Yes, sir.
Now come to the next point. Suppose I want to multiply by a constant. Okay. So I had observation these all things, right? 1, 2, 3, 4, 5. Suppose I want to multiply by 2, then what will be my new data set? Old is 1, 2, 3, 4, 5. Okay, this is
2,
old
4,
data set.
6, 8, 10 will be the new
Correct.
data
So
set.
2, 4, 6, 8, and 10, right? This is the new data set. What will be the mean of this data set now?
30 by 10, which is 3.
2 times the old mean.
What is 4 to 6
6,
is 12, 20, right?
6.
2, 4, 6 is 12, 12, 8, 20, 30. 30 divided by 5. So this is the 6, right?
6.
And mean for the old data set was
3.
right? And mean for the new data set is what? 6. That means
3
can I
plus
say
3.
3 into 2?
Yes,
Right?
sir.
So
Yes, sir.
old mean, right, into this is the constant, right? Because I had multiplied by 2, correct?
Yes, sir.
So can I say new mean is same as the old mean into that constant?
Yes.
Yes, sir.
In general, I can say y bar is the same as the x bar into c, right?
Sir,
Yes, sir.
if we multiply by 2.5,
Okay, what is the meaning of constant? Constant can be anything, right?
Change.
Yeah. If you can multiply by 2.5, you can multiply by 1.23, you can multiply it by 5.02, you can multiply it by 9.001. You will get the again same formula, old mean into that constant. It is clear for everyone?
Yes, sir.
Yes,
sir.
sir.
So that means
Yes,
there is no issue for even or odd.
No. Okay, what is the mean? Mean is nothing but I'm adding all the constant and divided by number of observation. Doesn't matter about even observations and odd observations, right?
Okay, sir.
Okay, let me cover the median and what, then I will come to effect of outlier to these three, all these three. Okay. So yeah. So what is the median? Median is what?
Middle value.
Middlemost observation of a data set.
Yeah. So in layman term, I can say median is nothing but it is an observation which divides my whole data set in two equal parts, right?
Yes.
Right, sir.
Correct?
Yes, sir.
So it's the let me write like it divides the data set into two equal parts, right?
Yes, sir.
Yes.
So there are two you can say two type of method or two kind of criteria to find out the median. So first is we have to observe whether your number of observation is odd or even, right? If your number of observation is odd, then what will be the median? Median will be middle observation.
N plus 1 by 2.
Middle observation, sir.
That means by the formula I can say n plus 1 by 2th observation, right?
Yes.
Correct.
Yes,
Now
sir.
if n is even, then my median will be, it's a nothing but you can simply you can say in the statement median is nothing but the when n is even mean of the two middle observation, right, in the ordered list.
Yes.
So first is we
Yes,
have
sir.
to arrange the data in ascending order, right?
Yes.
Okay. So after that, you have to see whether n is odd or n is even. Okay. So if n is even, then what we have to do? Basically, we have to find out the mean of two middle observations. Okay. In the ordered list, means in the which I mean after arranging the data set in ascending order. So that means I can say in terms of formula. So I have to take the average of what? N by 2th observation
N by 2 plus 1 observation.
and n by 2 plus 1th observation, right? So we have to take the average of these two. So average of these two means what? N by 2 plus 1th observation plus n by 2 plus 1th observation divided by 2, right? That is the mean.
Yes,
Okay.
sir.
So it is clear median. Now,
So, but for, till week 2, we have read that both the observations are median.
okay, that's for the categorical data, right? How you can take the average of categorical data? You can't take
Yes,
a plus a divided by 2, right?
Yes, fine.
Okay. Now, so suppose I have data set, let's say 2, 3, 1, let's say 5, 6, 7. Okay. So first of all, what you have to do? We have to arrange in ascending order, right? This is the first step, right?
Yes.
Correct. So what will be ascending
Yes,
order?
sir.
1, 1, then 2,
2,
then
3,
3,
5,
then
6,
5,
7.
6, 7. Right. So now what is the next step? We have to see whether n is odd or even. So here odd because we have 7
It's odd,
observations.
sir. 7, sir.
7 observations, right? So what will be the median?
N plus 1 by 2.
So n plus 1 by 2th observation, right?
3 is a median, sir.
So n plus
Yes.
2th, so 7 plus 1 by 2th, that means 4th observation, right?
4th observation.
So 4th observation is
3.
what? 3. So simply you can see if it's odd, so you have to see the middle observation. So this is the
Sir,
first
we can
3.
do like we can count first 3 and last first 3 and
That's
middle.
that's why I have blue
Instead of
mark.
using the formula like n plus 1 by 2.
Okay. So formula is okay. Suppose you have 100 data set. I mean 100 observation in your data set. Then it's the counting. I mean counting first, right?
Yes,
I mean,
it will be
difficult.
tedious. It will be difficult, sir.
So that's why formula is there. Okay. So I'm writing the formula because you should get the idea. So from here you can simply get the right. So this is the last 3. This is the first 3, right? So this is the middle observation, right? Now,
Yes, sir.
suppose I'm taking another example. Like say, suppose I'm taking the observation instead of this. Suppose I'm taking 1, 1, 2. Okay, one more 2. So what will be in ascending order? It will be 1, 1, 2, 2, 3, 5, 6, 7, right? So here n is even number of observations because we have 8 observations, correct?
Yes, sir.
So
Yes,
what is
sir.
the median? Basically, median is the, if you see, mean of the 2 middle observation, right? So you have one more way, mean of the 2 middle observations. So last 3 is this one, right? First 3 is this one, right? So what is the middle 2 observation are? These 2,
2 or 3, sir.
right? So what is the mean of these two? So
2.5.
2 plus 3 divided by 2. So 2.5 is the median. And by formula, what is the formula? Average of the n by 2 plus n by 2th observation plus n by 2 plus 1th observation, right? Divided by 2.
Yes.
So what is n by 2? 4th observation plus 5th observation, right? Divided by 2.
Yes.
So what is the 4th? If you see, 4th is 2 and 5th is 3. So again, you will get 2 plus 3 by 2, that is 2.5. So median is clear to all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Now, the same property, suppose I want to add a constant, okay? So I'm taking this observation, okay, in ascending one, okay? I'm taking the ascending one data set. So 1, 1, 2, 3, 5, 6, 7, right? Suppose what was the median for this data set? 3, right?
Yes.
Now, suppose I want to add a constant 2. What will be a new data set? 3, 3, 4, 5, 7, 8, 9, right?
Yes.
What is the median for this new data set?
3 plus 2.
6.
3 plus 2.
Sir, what sir? Multiply by 2.
Add. I have add 2.
Okay, sir.
So what is the
Five.
median of this new data set?
5.
5 will be
So 5.
5,
Sir,
right?
5,
That
sir.
means can I
5.
say 3 plus 2? So this 3 is the old median, correct?
Yes.
And this 2 is the constant, right?
Yes, sir.
Yes, sir.
So it's simple. Can I say if I want to add a constant, right? Then to old data set, then my new median will be, I'm writing median as empty, old median plus that constant, right?
Yes.
It is clear to all of you?
Yes,
Now,
Yes.
suppose I want to multiply it by a constant to this old data set. Suppose I want to multiply it by, let's say multiply by 2 again. Okay, so Dhanya, can you? Because those who have not any doubt, so please mute also. Okay. Suppose I want to multiply it by 2 this old data set, then what will be my new data set?
2,
2, 2,
2,
4,
4, 6, 10, 12, 14.
10, 12,
Right.
14.
And what will be the median? New median?
Median is 6, sir.
6.
What is this? This is 3 times 2.
3 into 2.
So what is this 3?
Old
This
median
3 is
into the constant, sir.
correct. Old median into that constant. So can I say if I want to multiply it by a constant C to my old data set, that means xi into C, yi. So new median of my new data set, or you can say new median will be old median into that constant.
Constant.
Correct?
Yes.
The
It is clear
constant.
to, it is clear to all of you?
Yes, sir.
Yes.
Come to the mod. Okay. So mod is nothing but, what is mod? I think mod is you guys are familiar with
Most
this
number
mod.
of observations.
Correct.
Highest frequency.
So mod is nothing but maximum frequency, right?
Yes, sir.
Yes, sir. Highest
Maximum,
frequency.
yeah, highest
Yes, sir.
frequency
Highest
of
occurrence.
the occurrence of an observation, right? So let's say that I'm considering the data set 1, 2, 3, 4, 4, 5. Okay. So what is the mod of this data set?
4.
4,
4, right? Because 4 is occurring more number of times, that is 2 times. Okay. So this is the something there is called unimodal, bimodal, and multimodal. So bimodal and multimodal is, suppose I'm saying 5 is occurring 2 times. So there is mod is 2, right?
Bimodal, sir.
So
4
it's
and 5 are highest frequency, sir.
highest. Okay. Suppose I'm saying there are 2 6 also. So mod is 4, 5, and 6. So it's a multimodal. I mean more than 2, right? And suppose in this data set 6 is occurring 3. So what is the mod? Mod is 6.
6.
It will be unimodal because 6 is occurring more number of times, which is 3. Correct?
Yes,
Yes.
sir.
Mod is clear? Okay.
Yes, sir.
Suppose, yeah, I'm taking the data set 1, 1, 2. Let's say
Sir, mode is 3 or 6?
mod is 6, but 6 is occurring 3 times.
Okay, sir.
Okay. So here mod is what? 4.
4.
Okay.
4, sir.
Suppose I want to add 5 to this old data set. Then what will be the new data set? 6, 6, 7, 9, 9, 9, right? What will be
Yes,
the
sir.
mod of this new data set?
9.
9.
What is this 9? 5 plus?
5 plus 4.
So what is this 5? This is the constant. And this 4 is the old mod, right?
Old mod.
Old mode, sir.
So I can simply say new mod is same as the old mod plus
Mod plus constant.
Plus constant.
Constant.
correct. Now Suppose I want to multiply it by 3. Then what will be my new data set?
3,
3,
3,
3, 6, 12, 12, 12.
What will be the mod
12,
then?
sir. 3,
12,
4.
12.
So what
Old
is this
mod
is?
into C, sir. Old mod
4
into
into
constant, sir.
correct. So this 4 is the old mod into
Constant.
C.
constant.
So similarly, I can say from here, new mod is same as the old mod into
Constant.
constant. So far, it is clear to all of you.
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes,
Now
sir.
let's see the sometimes if you have seen like effect of outliers on these three measure of center tendency, right? What is the effect of outliers on mean? What is the effect of outliers or median on models, right? So outliers is what? Anybody wants to explain?
Extreme values of a data set.
Extreme value of a data set. That is something which is far from your normal observations, right?
Yes.
So let's say let me consider one example. So suppose I have one data set 1, 2, 3, 4, 3, 6, 4, 10, right? So 10 and let's say 10, 6, 20. Okay. So this is the suppose I'm considering one data set. Okay. Now tell me what is the mean of this data set?
3.
3.
8.
No, let's say let's make it as 5. Okay.
2.6.
Okay, let's make
3.
it 5. So it's a simple, right?
The 15 by 5, 3.
It's
3,
a
sir.
3.
3.
Right?
Yes, sir.
Okay. Okay, one second. Let me take one more data set. Let's say again it's a 5, not 5, 2. Okay.
Yes.
One second. Okay. Now tell me. Let's take this example. That will be okay for us. So 1, 2, 3. Okay. 4, 5. Okay. Let's say 9, or let's make it as 3 again. Okay. Okay. So what is the mean of this data set?
3.
3. 18 divided by 6, which is 3.
3, sir.
Now, and what will be the median? Median will be what?
3.5.
So we first we have to arrange in ascending order. So 1, 2, 3, 3, 4, 5. So median will be average of these two, right?
Yes, sir.
So 6 by 2, which is 3 again, right?
3 again.
Right? What is the mod?
3.
3, sir.
3,
Now,
sir.
3.
suppose in the place of 5, okay? Suppose initially you had the observations like 1, 2, 3, 3, 4, 5. Okay. Suppose I had this one. Instead of 5, suppose you had 500. Okay. So what will be the mean? Anybody? So it will be 2 plus 1, 3, 3, 6, 6, 3, 9, 9, 4, 13, 513 divided by 6, right?
Yes, sir.
Yes.
Yes, sir.
Which anybody can calculate it?
85.5.
85.5. What is the median? Median is again 3. Mod is 3, right?
Yes.
Correct?
Yes, sir.
So if you
Yes.
see carefully, this is something which is extreme value,
Yes, sir.
correct? If you
Yes, sir.
observe carefully, initially my mean was 3, right? For the
Yes.
this data set 1, 2, 3, 3, 4, 5, right? But when a extreme value was there, outlier was there, means that there is a lot significant change in the mean, right?
Yes, sir.
So can I say mean is affected by the outliers?
Yes.
Sensitive by outliers.
Okay, because if you see, mean is there is significant change in this mean and this mean due to one observation, right? But
Sir, can you explain the outlets? I didn't understand, sir.
so outliers is what? You can say from here, all the observations were 1, 2, 3, 3, 4. But this is the something extreme value, right? Which is far from the normal
sir.
observations, right? Too much, correct?
Yes,
Now,
sir.
if you see in the case of median, median is the same,
Not
right?
also same, sir.
Mod is also same.
Yes, sir.
But basically median and mod are least affected by outliers. Okay, you can't say it is not affected by outliers. Okay, so why it is least affected by outliers? Suppose you have a small data set. Suppose I have data set 1, 3. Okay, so median of this data set will be what? 2.
2.
Correct. But suppose in the place of 3 you have, let's say, 300, then your median will get changed, right?
Yes, sir.
So median is affected by outliers in the case of a small data set, and it's the least affected, but mean is affected by outliers. Okay, same case for the mod. It is okay?
Yes.
Yes,
okay,
sir.
so there is one more concept which is called the range. Okay, what is the range of any data set? How you can find the range of data set?
Maximum value minus
Maximum value minus minimum value.
Maximum value minus minimum value. Now, tell me the range of this data set.
4.
4.
4, sir.
Okay, 4. And what is the range of this data set?
499.
99. So basically, range is also affected by the outliers, and range is sensitive to outliers. Okay.
Yes.
Range is very sensitive to outliers. You can say because your outliers will be is the extreme values of your data set, right? Suppose in the place of 500 you have 5,000, so your range will be 4,999, right?
Yes, sir.
So you got the idea. Range is basically sensitive to outliers. Okay. So these all four concepts are clear to everyone. So we can move
Yes.
we'll move to the measure of dispersion. Okay.
Yes.
So what is the measure of dispersion? Anybody? So see from
Sir,
here you
can
can
explain
see.
the variance, sir?
I will come to yeah.
Okay, sir.
So from here it's clear, right? So you can't say mean and median and mod is not affected. It's the least affected by outliers, depend on your data set. But mean is affected by outliers, right?
Yes.
Okay. Now, so now let's move to the measure of dispersion. Okay. So what is the meaning of measure of dispersion? I'm asking about terminology.
They indicate the spread of a data set.
A spread of the
Yes,
data set, right?
variability or spread of data set.
Correct. A spread of a. I think you guys have studied very carefully. That's great. Okay, so what are the measure of center tendency? So not center tendency, measure of dispersion. Hello.
Yes.
Yeah, what are the measure of dispersion?
Range, variance, standard deviation, and quartiles.
Correct. Range is also I studied. I taught the range initially, but range comes under the measure of dispersion. Okay. So after range we have variance. And
standard deviation and quartiles.
Okay. So let's come to later quartiles and all. Let's cover it range and all. Sorry, range we have done. We'll study about variance and standard deviation. Okay. Now tell me. So variance, there is two type of variance. One is called population variance. Okay. And one is for the sample variance. Okay.
Yes, sir. Sample variance.
So what is the population variance? So population variance, if you see, it's nothing but, it's sometimes denoted as sigma square, which is nothing but 1 upon n, okay, summation of I is equal to 1 to n xi minus x bar whole square. So what is the meaning of this one? So this means we are seeing the difference or distance, or you can say variability of the observation from its mean value.
Mean value, yes, sir.
Okay. The sample variance is, in the sample variance we are dividing by n minus 1 in the place of n. Okay. So this is the same as this. Okay. You will study in stage 2 and all why we are in case of sample variance we are using n minus 1. What's the effect of using n and all, and minus 1 you will get it later. But so far just keep in your mind, for the population variance we have to consider all the observation. In the sample variance you have to consider the n minus 1. Okay. The same thing standard deviation, right? So how you can define the standard
The
deviation?
root of, sir. The root of.
Okay. Square root of the positive square root of the variance, right?
Yes, sir.
Yes.
Okay. So what about population standard deviation?
Root of sample variance.
So
sir.
square root
Root
of
of
sigma square, right?
population.
Yes.
That means, square root of 1 upon n summation of xi minus x bar square, right? And same case of the population standard deviation. Okay. So now let me ask one question. Why we are using the standard deviation? Because the only difference from variance and standard deviation is the difference of the square root. Okay. But why we are using what's the importance of standard deviation? Anybody? Because things are the same. If you are saying square root 4, that means you are getting the 2. Then what's the importance of that standard deviation?
If the units in variance contains, if the values in variance contains, for example, units as kg, then it will become kg square. So that's why we are taking roots. So get to convert the unit square into unit.
Okay, suppose you got that. Then what's the importance of that? I mean, it's a easy to compare basically the final things, right? So it's correct. Suppose your observations, your x's are nothing but, let's say, weight of persons is given to you, right? So if your initial unit of your data set in kilograms, correct? But when you will find the variance, you will get the final value. Let's say I'm saying 72.5 kilogram square, because I'm doing the xi minus x bar square, right? This is something, correct?
Yes.
So, but it's a kilogram square, right? But your original unit was is kilogram. But if you will take square root of this variance, then you will get the answer in kilogram, right?
Yes.
The same unit of your data set. So that's why standard deviation comes in to the picture. It is clear to all of you?
Yes,
sir.
Now
Yes,
let's
Yes.
see the effect of, as we have seen,
Sir?
adding. Yes.
Sir, can you please explain sample versus population one more time?
Okay, so there is only one difference for population variance and sample variance is, in case of population variance, we are using in the denominator n, and in case of sample variance, we are using in case n minus 1. The reason behind it.
Sorry, X bar is mean.
Sorry?
X bar is mean only, right?
Yeah.
And xi is the observations.
Xi is the observation. Yes.
And n is number of observations.
Sorry? Yes, n is the number of observations.
Yes.
Yes. So why we are using this n and n minus 1? So this is something you will study in stage 2 course. Okay. So far you can just keep in your mind. So, or you can explore it on your own, or else if you want, then we'll discuss it later also. The reason behind it, why it's the n, why it's the n minus. I mean, there is one level of statistics is, involved, because if you study it later. So there is one concept, it will called unbiasedness. So what will happen in case of unbiasedness? So we have to do expected value of your statistic, means sample parameters should be equal to the population parameter. So in that case, we have to use the n minus. I mean, and related to x bar and all, we are measuring the x bar. So 1 degree of freedom will less. So that's all. I mean, these all type things.
So
will
for
have to be-
standard deviation for root over variance, we will take population variance.
No, you can take, no, it will be clearly mentioned whether you have to find the population standard deviation or sample standard deviation, right?
Okay, sir.
If
Okay,
it's
sir.
mentioned sample standard deviation, then you have to take the square root of the population variance.
Okay, sir.
Okay. Now,
Sir, what
come
is the
to-
difference between, sir, the population and the sample, sir? That
That's-
variance.
I told just a few minutes before, not minutes, also within second, right? The only difference is in the denominator we are using n, and sample variance we are using n minus 1. Okay. The
Okay,
reason
sir.
you will study it later, or you can explore. I told you unbiasedness concept will the region, one of the region. Okay.
Okay,
Now,
sir.
come to this adding a constant, right? Because we have seen the adding a constant in case of mean, median, and mod also. Same case you can treat for the range also. So suppose, okay, so I will consider. Okay, so those who have not done, please mute yourself. Okay. So now I will take only one. I will go through the population variance. Okay. I hope you can do the same for the sample variance. Okay. Now, so or let me take the sample variance itself. So who is this Kumar Avinash? So it's a request to all of you. If you do not have any doubts, so mute yourself. Okay, keep mute yourself. Otherwise, class will get disturbed, right? So there is no matter. Okay. So I'm taking the sample variance case. So this is the 1 upon n minus 1 summation of I is equal to 1 to n xi minus x bar square. So we'll see what is the effect of adding a constant or not. Okay. So suppose I have observations xi is the old observation, right? I goes to 1 to n, right? And suppose I want to add a constant c to my new observation old data set, then my new observation will be what? Xi plus c. Correct? This is okay for everyone?
Yes.
Yes, sir.
Yes, sir.
What will be the new mean?
Yes, sir.
Old mean plus
Old
C.
mean plus
Right?
C.
I mean, are you able to relate with this notation?
Yes, sir.
Yes, sir.
So suppose for my old data set, my variance is this one, right? Now, come to the point. Suppose I want to add a constant, right? So what I will get? Okay, so what will be my S square new variance? So my new data set is yi, right?
Yes.
So can I say since I is equal to 1 to n, yi minus y bar is square? Okay.
Yes.
Yes, sir.
Okay, tell me. 1 upon n minus 1 summation of I equal to 1 to n. In the place of yi, can I put xi plus c?
Yes.
Yes, sir.
Minus in place of y bar, can I put x bar plus c?
X plus
Yes, sir.
Correct? No.
C getting eventually cancelled.
Correct. So it will be I is equal to 1 to n. So I will get xi plus c minus x bar minus c whole square. So c will get cancelled out, right? So what I got here, 1 upon n minus 1 summation of I is equal to 1 to n xi minus x bar whole square. So what is this? This is the variance of old data set, right?
Yes.
Can you see? This is the variance
Yes,
of old
sir.
data set, right? Initially, I
Yes.
started variance of new data set, but at the end, after adding the constant, I got a variance of the old data set. So it simply means when you want to add a constant to all the observation, then variance of new data set will be same as the variance of old data set. That means there is no effect of adding a constant in case of variance.
So it is not affected by the outlet node, sir, the variance and standard deviation.
That's I have derived here, right? It is
Yes,
not
sir.
affected. that is, it's not affected by adding a constant, right, to the observation. Okay. Now,
Okay.
it is clear adding a constant.
Yes, sir.
Now,
Yes, sir.
I want to multiply by a constant. Okay. Suppose okay, I want to multiply by a constant. So my new data set will be what? Xi times C, correct? And initially, if your observations x1 to xn, then my variance was what?
1 by n minus 1.
Sample variance.
Sum of
Sample
I to
variance
n,
basically.
x1 minus x bar the whole square.
Correct. So let's consider new variance. Okay. So 1 upon n minus 1, summation I is equal to 1. New data set, it will be yi minus y bar square, whole square, right? What will be the y bar here? X bar into C, right?
X by C.
Yes, sir.
Now, so can I do 1 upon n minus 1, summation I is equal to 1 to n, xi times C minus x bar times C. Okay.
Yes, sir.
Now, C is the common here.
C square common outside.
So C square will be
Yes, sir.
outside.
C common outside.
Correct. So what is this? What I got? Can I write C square into 1 upon n minus 1, summation of I is equal to 1 to n, xi minus x bar square, right?
Yes.
So what is this quantity? This is old variance.
S square.
So what?
Into the C square.
Correct. Into the C square. So what we got here? New variance is the square of the constant times old variance, right? If I want to multiply by a constant to my observations, old data set. Okay. This is clear to all of you in case of variance.
Yes, sir.
Okay. So the same things I can do in case of standard deviation. Okay. So new standard deviation will be same as the
old standard deviation.
In case of adding a constant, right?
Constant, sir.
Or here it will be new
Multiplying a
standard
constant.
deviation C times
C square times. Yes,
Y
sir.
square.
C.
No, here
Not square, right?
C, not squared.
Not C. Sorry, not square. Why not square? Because we have to take the square root.
Square root. Yes, sir. C, sir.
Okay. So far it's clear to all of you?
Yes.
Yes, sir. Yes, sir.
Adding a constant and all things, right? So
Yes.
the same thing you can do for the population variance. So we have generalized. So we can do in general way also for the variance, because only difference is divide by n and n by n. You will get the same result. Now come to the another concept which is called the percentile. Okay. So anyone can tell me what do you understand by the percentile?
Below which
Yeah. Don't hesitate. Just see. I mean, just say the answer. Okay, it's not. So everyone will get the idea. What do you understand? Okay. Any one of you?
The percentile, suppose 70 percentile, sir. So if a student have got some 70 percentile means he had done 70 percentage of the students he have done better, sir. Out of like that, sir. 70 percentage.
percent of distribution, that is the percentage of students as compared to whom you have performed better in a particular exam. For example, you've got 90 percentile, so it means that you are better than 90% of the total population.
And you are below than 10%.
10%. Yeah, below 10.
Below 10. That's clear to all of you?
Yes, sir.
Normally, I think in J and all, it's this criteria is using, right?
Yes.
J.
Yes, sir.
Yes,
If
sir,
you will
in
give,
J and
yeah,
Newton.
if you will give GRE exam and all, then this funda is using actually percentile. Means suppose I'm saying I got 85 percentile. So that means I'm more than my marks is more than the 85% of the student. Not 85% is the marks, right? My marks is more than the 85% of the student, and my marks is less than the remaining 15% of the student. Okay. So let me generalize which definition has been used in the lecture video. Hope correct. So sample 101 minus p percentile means okay. This means what? Anybody? That means data value having the property means at least 100 p percentile of the data are less than or equal to it, and at least 101 minus p% of the data values are greater than or equal to it. Okay, I mean, let me take that example. Suppose 90 percentile. Okay, so that means suppose this is the data set. That means suppose this is 90 percentile. So that means 90% of the data is less than, at least 90% of the data set is less than or equal to it, and remaining 10% of the data set is more than it. Okay, that is the meaning of the percentile. You can do in fractions also. So there are two kind of like I mean there is procedure for finding the percentile. What are those? There are some procedure to find, to calculate the percentile of a data set. Anybody?
First, arrange the data in ascending, increasing order.
Okay, one second. Idea of the percentile is clear to all of you?
Yes, sir.
Yes. Yes,
Okay.
sir.
So there is one method to compute the percentile. It's called 100 p percentile, 100 p percentile of a data set of size n. So first step is, someone was saying, right, arranging the data set, right?
Arranging the data set in ascending order.
Increasing. Yeah, increasing, yeah, ascending, both are the same. Okay. And what is the next step?
You have to multiply n into p.
Correct. We have to multiply n and p. So there is two criteria. This n into p may be integer, may not be integer, right?
Yes, sir.
It's possible, right? So if np is not integer, then what?
You have to round off to the nearest and then
Round off to the nearest. So we have to
So what is
consider the np.
number of
np, yeah,
observations.
I will come to this point. So n is the number of observation, p is the percentile. Suppose I ask 98th percentile. So value of p will be 0.9. Okay.
Yes, sir.
Yes, sir.
So that value, see, suppose n, okay, suppose n is 10 and p is the 0.5. So you will get 5, right? So
Yes.
this is an integer. Suppose n is the 10 and p is the, let's say, 0.75. So value of n into p will be, means 10 into 0.75 will be 7.5, which is not an integer, right? So these two cases may occur there, right?
Yes, sir.
Okay. So when np is not integer, then we have to consider, or we have to determine, let me write down we have to determine the smallest integer, right?
Greater than NP.
Greater than this np.
NP.
Sir?
Yeah, I will explain. Yeah, please go ahead.
Sir, if it is 7.6, we'll consider 8, and if it's 7.4, we'll consider 7,
Yeah,
right?
yeah.
So what if it is 7.5, sir?
No. If it's 7.1, you have to consider the 8.
Yeah. Okay. Even if it is okay.
What I have
greater
written?
than.
If np is not an integer, determine the smallest integer
Ah.
greater than np.
Okay. Fine.
What
sir.
is meaning of smallest integer? I will come to you. I will come.
Ah.
Okay. So now, so this will be so next. So in smaller integer greater than np. So that will be that observation on that position. Okay. Or you can say the data value in that position is the required percentile, right?
Sir, is it like greatest integer function we used to do in mathematics?
Kind of. There is something when suppose consider your np is not integer. Sorry, np is integer. Okay. If your np is integer, then what you have to do? I have to take the average of the values in the position np and np plus 1. Let me, okay. So we have to take the average of the values, right? Average of the which values? If np is integer, in the position np
and NP plus 1.
Okay. Many of you are like, what is this I'm explaining here? Okay, so it will clear within a minute. Okay, is the required percentage. Now, so let me take of the data. Let's say let me consider data set. Let's say I'm considering 10.
So can you solve that activity question?
11. I will come to that. Don't worry. Let me explain one thing. Okay. Okay. Suppose 8. Okay. Suppose this is the data set. Okay. And for this data set, I ask calculate the 50th percentile. Okay. So what is the 50th percentile?
11. It is the median.
No, not asking the answer of this question. What is the 50th meaning of the 50th percentile?
It's the median.
Median. Because 50th percentile is 50% of the data will be less than and greater than. That means two equal part, right? So 50th percentile means median, right? Which is the definition of median. So what is the first step? Let's go stepwise. What is first step? We have to arrange the data in ascending order. So it will be 7, 8, 10, 11, and 12, right? Correct?
Yes, sir.
Okay. Next step is we have to calculate the n into p. What is the n here? 5.
Number of observations.
5 observation we have 1, 2, 3, 4, and 5. What is the p? I asked 50th percentile. So that means p is the 0.5. So 0.5. So what is the value of 5 into 0.5? 2.5. Now, can you see NP value of NP is not in integer.
It's not an
Right?
integer.
Not an integer.
So if it's not an
it is
integer, then
rounded
what
off
we have
to
to do? We have to consider the smallest integer greater than this, right? What is the meaning of smallest integer? So what is the smallest integer greater than this? That means 3, which is 3. So 3 means you have to take the
Third
third
position.
observation, right? So third observation is what?
10.
10.
So 10 is the 50th percentile this data set. This is the procedure, right? So now, so what is the meaning of smallest integer? So see, integer can be greater than, can be 4 also, 5 also, right? But we have to consider the smallest one after this. Now, so if I ask to, suppose the question is compute the medians, then you can directly can say the 10, right?
Yes.
Correct. So now you got what is the 50th percentile? 50th percentile is same as the median, right?
If it is 25 percentile, it is 0.25. It is 0.25 also into number of observation also.
What 25th percentile?
How you can find, sir? It is 0.25 into 5 also.
Yes. So what will be the value of 0.2? Okay, let's compute that one. Your n is 5, p is 0.25, right?
0.25, yes, sir.
So NP will be what? 5 into 2, 5 into 0.25. That means what? What is the value of 5 into 0.25? 1.25?
1.2.
That means
1.25.
Smallest greatest integer is what? 2?
Yes, sir. 2.
So that means second observation. So 8 is the 25th percentile, my data.
Percentile, sir. Yes, sir.
Okay. Okay. Let me take one more. Let's say suppose I'm asking 80th percentile. Okay. 80th percentile of your data set. So what is your n? 5.
5.
P is the 0.8. What will be the value of NP?
4.
Now see, here 4 is an integer, right? So that means what? What we have to do? We have to take the
4 plus 1.
4 plus 1. So we have to take the average of the values which are in NP and NP plus 1th position. That means we have to take the average of values which are in the 4th and 5th position, right?
Yes.
Correct. So what observation are in 4th and 5th observation? 11 and 12. So average of 11 and 12 will be 80th percentile of my this data set, right?
11.5, sir.
11.5 is the 80th percentile of this data set. It is clear to all of you?
Yes, sir.
Yes, sir.
How you can find
Yes,
the
sir, clear.
percentile. Okay. Now, so next concept are quartiles, right?
So please solve that assignment, sir, because I'm having a problem in that question.
In which question?
Activity 3.5, question number 4.
So what is the problem?
So for ninth percentile, how we will calculate 0.09?
Yes. So n into 0.09. What is the n? N value of n is 9, right? So 9 into 0.9, 0.09 will be what? 0.81?
Yes, sir.
0.81 is integer or not?
Not an integer.
Not an integer. Then what will be the smallest integer?
Acha, then the first value will be
Yes,
considered, no?
that's all. First, I think 15 is the answer. Here
Okay,
you have
sir.
to arrange in the ascending order, right?
Yes, sir. Now I understand. Thank you, sir.
Okay. So quartile. Okay, so what is meaning of the quartiles? Anybody? You know, quarter, right? 1/4,
Yes, sir.
right? So quartile means what? It's a simply, you can say, suppose I have this whole data set, right? So quartile 1/4 means what? We are dividing the data set in 4 parts, right?
Yes.
Kind of this, right? Yeah.
Dividing in 4 equal parts.
I mean, it's somehow it's a distance is not same, but treat it as same. Okay. I mean, just treat it all the
Yes.
distance as same. So this is the Q. This is called the Q1. Q1 means first quartile. Okay. This is called the first quartile. What is the first quartile? Means 25% of your 20, simply 25th percentile, right?
Yes.
This is dividing your data set in 2 equal parts. That means 50th percentile, right? This is called 75th percentile.
Yes, sir. And 900.
And this is the maximum value or 100 percentile, right? So this is something called the quartile. It divides the each data set into quarters, right? Means 25%, right? So if each part is of 25%, then this Q1 will be 25th percentile, right? And Q2 will be, this is called the Q2. So Q2 will be what? I have written 50th percentile, means 25 this plus 25. Then only then this point will be 50th percentile, right?
Yes.
Correct? This
Yes, sir.
This is called the Q3, means third quartile. So what will be this I have written 75th%. That means this 25th plus this 25th plus this 25th. Only then this will become 75th, right?
Yes, sir.
Yes.
Yes.
So this quartile is clear?
Yes, sir.
Clear, right? Q1 is the first quartile, that means 25th percentile of the data set. Q2, 50% of the data set, and Q3 is the 75th percentile of your data set, right?
Yes.
And there's one something concept called 5-number summary, which is anybody can tell me what is the 5-number summary?
Like it has minimum, Q1, Q2, Q3, and maximum.
Correct. So one concept called the 5-number summary. Okay. So 5-number summary involves the minimum value, okay, of your data set. Second is Q1, Q2, Q3, and maximum value of your data set. Okay. This is called the 5-number summary. Okay. So Q1 is called, first quartile, right?
Yes.
And Q2 is what? Second
Second
quartile.
quarter.
Q3 is what? Third
Third
quartile.
quarter.
Okay. So actually, box plot. Anybody?
Yes, a candlestick chart.
Yeah. So box plot is basically about this one. So box plot, suppose this is the plotting this one. So this is the box plot. So this things represent the minimum value, and this one represent the maximum value, and this will represent the Q1, and this will represent the Q3. Median will be in between of Q1 and Q3. I mean, it's not like that it will be exact middle of these two. It can be anywhere based on your data set. It can be at this point, it can be at this point. Based on the data set, Q2 will be in between of this Q3 and Q1. Okay. So this is something called the just a representation of the 5-number summary. Okay. So next
Yes.
it is interquartile range. Okay.
Sir, what is it called again? 5 number?
5-number summary. It's called 5-number summary. First is minimum value of your data set.
5 numbers.
First quartile, second quartile, third quartile, and maximum value. Okay.
Yeah, 5-number summary. Am I
Yeah,
right, sir?
5-number. It's just a terminology. 5-number summary. Okay.
Yes, sir.
So next step is IQR, interquartile range. So short form is this for IQR. I means interquartile range. So IQR is defined as nothing but difference between Q3 and Q. Suppose I have given a data set to you and I ask what is the IQR. So what you have to do, you have to first compute the Q3 and Q1. For that, you have to arrange the data set in ascending order. Then you have to compute the NP, then and all, and you have to find the Q3 minus Q1. Okay, I will come to this point how to compute the Q3 and Q1. Okay, let me compute the Q3. Let's go. I think I have computed. Okay. Let's consider this data 7, 8, 10, 11, and 12. Okay. So 7, 8, 10, 11, and 12, which is already in ascending order. So keep in mind during the examination and all, this is the normal mistake made by the students. They did not arrange the data set in ascending order. They directly started computing n into p and they got the wrong answer. Okay. So don't do that. Keep in your mind, first I have to arrange the data set in ascending order, then you have to proceed further. Okay. So suppose I want to compute the IQR of this data set. So I have to compute the difference first Q3 and Q1, right? What is the Q1?
8.
25th percentile, right? So 25th percentile means what? What is your N?
5.
What is the P?
0.25.
0.25.
So next step is value of N into P.
1.25, which is 2, sir.
So 1.25, which is, that means I have to consider the second observation.
Yes.
So 8. So value of Q1 is the 8, right?
Yes.
Yes.
Now, what is the Q3? 75th percentile, right?
Yes, sir.
75th percentile means my P is
0.75.
So what will be the value of N into P? 5 into, that means 3.75.
Which is 2, sir. Fourth
That
observation, which is
fourth
12.
observation, right? Since it's not an integer, so we have to consider the next smallest integer, right? So fourth observation is what? 11.
11.
So Q3 is 11. So what is the IQR of this data set? 11 minus
9.
11 minus
3 is the interquartile range of my data set. Okay. I mean, I hope
Yes,
you
So
guys
where
are.
it is used, sir, IQR, basically.
IQR is comes under the actually measure of dispersion. Okay. So it's one of the measure of dispersion. Okay? Like as we had done variance, standard deviation, and all things. So like see, we use of the that percentile and all, right? Quartiles and all,
Yes, sir.
right?
Yes, sir.
And IQR you can use while calculating the outliers of your data set, right? Let me explain you. I think you will get the idea. So there is one criteria to compute the outliers. So that criteria is you to compute, you to see outlier is something defined as which is less than Q1 minus 1.5 times of IQR, and you can find the IQR, outliers if your outliers is greater than Q3 plus 1.5 times of IQR. Okay. So this is something formula to find the outlier. Okay, let me explain. So I have observation this. Okay, I have data set 7, 8, 10, 11, and 12, right? And I want to know whether outliers are there in or not. Outliers are in this observation or not. Okay. So what you have to do, you have to find the Q1. So what was the Q1? Q1 was 3, right?
Yes.
And we have computed IQR. IQR was 3.
Q1
Not
was
3.
8.
Q1 was 8. Q1 was 8. And Q3 was 11. Right? So now you just compute these two. So Q1 minus you have to see whether there is any observation which is less than this quantity or not, and you have to see is there any observation which is greater than this quantity or not. If there is any observation, you can find out that observation is outlier. So what is the Q1? 8 minus 1.5 times what is the IQR? 3, right?
3, sir.
So what will be the value of this one?
8 minus 4.
8 minus 4.5, that means 3.5.
Yes, sir.
Yes.
Okay, that means this criteria, there is no observation which is less than 3.5, right?
Yes, sir.
In this particular data set, right? Now compute the this quantity. So it will be 8 plus 1.5 times 3. So 8 plus 4.5, right? That means 12.5.
Sir, 11 plus, na?
Yes, sir.
Oh, sorry, 11 plus. Yeah. Correct. Great observation. So 11 plus 4.5, that means 15.5.
Yes.
Correct? Is there any observation in your data set which is greater than this
Sir,
quantity?
11 plus 1.5.
No, right? So that means there is no outlier in this data set, right?
Yes.
Clear?
Yes, sir.
There is 0 number of outliers in your data set. Okay. So for this, from these two, you can find out is there any outlier in your data set or not. Okay.
Sir,
Yes.
what if either condition is true?
Either condition is true, that means that is also outlier. Okay. You to check the both. Okay. Whether which one is true or not. Are you getting the idea? It can be, suppose there is any observation which is, let's say, -2. Okay. So -2 is the less than 3.5. I mean, I'm not saying -2. Okay, let's take any. Is there any question where outliers is there? Anybody can tell me? I think let's make it as -1. Okay, 7, 8, 10, and 11, for example. Whether, okay, let's see whether for this data set outliers is there or not. Okay, so what will be the Q1? Q1 will be 7, right?
Yes, sir.
I mean, N is the 5, P is the
There is a
0.25.
question in week 3 outliers tutorial, sir.
Outliers tutorial. Which tutorial?
Like it's week 3 outliers tutorial in week 3 content.
Okay. Let me see.
It's a video
Yeah,
lecture.
Okay, I got it. So because I just asked to see the data set. Okay. Yeah, as you can see, which I have discussed here, the same formula we have to apply. Okay. Apply to compute the outliers. Okay. I think this data set is very large. Let me see the value of Q3 and Q1. Okay. Okay, I asked about, so it's asking about effect of median and mean. Okay, which we have discussed already. I'm asking. Okay, let me consider. Okay, let's see this data. Okay, so
Sir,
Q1
actually,
is,
there was an outlier. The last one was actually the
Sir, there was
outlier.
an outlier actually.
where is this one? It's about mod till mod only.
So this is a third part of the question.
Sir, 55 has been removed from the data set, sir, because it's an outlier, sir. Yeah, 55 has been removed.
Okay. Yeah. See, now from here you can see Q1 is what? 26.5, right? Right. So Q1 was 26.5, right? And Q3 is 36.5, correct? Let me see. So as you can see from here, IQR was 10. So now you can see the same formula which we have applied, right?
Yes,
Q1
sir.
minus outlier should be less than Q1 minus 1.5 times of IQR, and outlier should be greater than Q3 plus 1.5 times of IQR. So from here you can see you have computed and we got 11.5, right? So is there any observation which is less than 11.5? No.
No.
Correct? But if you go further, Where is this computer Q3 plus 1.5 times of IQR? Okay, so Q3 plus 1.5 times of IQR, as you can see, it's a 51.5, right?
Yes.
Correct. Is
Yes,
there
sir.
any observation in your data set which is greater than 51.5? Yes. Which
Yes,
is
sir. The last.
55.
Yes, sir.
55 is the outlier for this data set. Okay. So you got the idea how you can compute the whether outlier is there or not. So you have to check the actually
Yes.
both condition. It's not like you checked only one and you got out there and you stopped. No, you have to check the whether both. I mean through the both conditions. Okay.
Yes, sir.
Yes.
I think I hope.
But should both conditions be satisfied?
No, it's not compulsory. See, this condition is for the lower minimum below the minimum value, and this condition for the above the maximum value. Okay. Basically, if you see the box plot, right? So this minimum value is sometimes considered as the Q1 minus 1.5 times of IQR. Okay. And this is the something Q3 plus 1.5 times of IQR. So observations below this is considered as the outliers, and observation above this considered as the outliers. Basically, okay. So box plot this part only. Minimum to maximum is free from outliers. Okay. So
Yes, sir.
outliers can be anyway. I mean anywhere, either below to this point or above to this point. Okay.
Yes.
Clear?
Yes.
I think I have covered all the concepts.
Yes,
If
sir.
I'm not
Everything
wrong,
is finished, sir, of week 3.
right? We have covered all the concepts. Okay. Is there any doubt?
Yes, sir. Without in activity questions.
Okay. So what you can do? Okay, I will be back in 2 minutes. Okay. After that, we'll discuss the rest of the doubt. Okay. You got the fund of all the concepts of week 3. Is it okay for everyone?
Yes, sir.
Yes.
All the concepts
Yes,
are
sir.
clear. Any questions
Everything
will
clear.
come from week 3, you will be able to do.
Yes, sir.
Yes.
Okay, great. Just wait for 2 minutes. I will be back. Okay.
Okay, sir.
Yes.
Hello. Hello. Am I audible?
Yes, sir.
Okay. So we'll discuss some doubts of activity and all. Okay, for 10 to 12 minutes. After that, okay, we'll wind up. Okay, so let me share my screen. From which activity we heard out? You heard out?
Sorry, AQ 3.5, question 10.
I think someone asked that question, right? If I'm not wrong.
It's the max question.
AQ10, range of the data set?
Sir, actually the range maximum value is 70, but minimum value according to the system it's 5, but it's actually 1, sir.
1?
Because in that box plot, the minimum value in that candlestick chart, the minimum value is just above 0.
No, that's not okay. That's not exactly 1.
Acha, okay.
Let me say. Okay, can you see?
No, sir, I don't see the screen.
Sorry. Let me share my screen. Just a minute. Now, if
Ah,
you
sir.
see, the unit difference from 0 to 5 is 5. There is a unit difference
Acha,
of
okay,
5.
you have to consider the unit difference as the minimum
Yes, it's a
value.
5, 0 to 5, 5 to 10, 10 to 50. It's not like 0 after it's 1. And the
Okay,
minimum value is about, I think, around 2.5.
Lekin, but
2.5
it
or
is
3.
sir,
right?
but it's accepting values from 64, 65, and 66.
Yeah, 64 to 60. That's why range is given to you, because
Yes,
here
yes, sir.
exact minimum value is not given. Actually. So you can consider is about, I think, if I'm not wrong,
if
3.
you,
Not
sir,
3, 2. 2,
but
2,
even if you're
right?
considering 5 also, it's getting the answer, sir.
No, if you consider 5, then how will you get answer?
70 minus
No,
5 is
70.
65.
Sorry. See, listen to me. 70 is not the maximum value. 70 is the maximum limit for y-axis. Maximum
Okay.
value
Is
Can
60.
you see something 68, around 68, right?
Yes, sir.
67. Because this box plot about this for this box plot, maximum value is this upper one, right? You
Yes,
can
sir.
see this below. Okay, let me draw it again. Suppose this is the my box plot. Okay. So
Okay.
this is represent the minimum value for data set. This represent the maximum value.
Maximum value.
Y-axis can be 1000. Doesn't
Ha.
matter. But maximum value you have to consider this
Okay.
corresponding to this. Okay.
Okay, sir. Fine.
Anybody else?
Sir, I have a doubt in activity 3.1, question number 5 and 6, sir.
3.1, question number
Sir,
5.
I have a few doubts. Sir, first of all, can you also explain a little bit more about percentile and quartiles and interquartiles? I did not understand that concept very clearly.
Okay, while I was explaining, you should ask me, right?
Yes, sir.
I was explaining, I think, few minutes before, then you could ask me at that point. Like, yeah, I'm missing here, lacking here. Again, I have to repeat again. Okay. Is there any question? I will explain along with that question. Okay.
Yes, sir. 3.5.
Yeah, let me complete this part. I will come to you. Okay. Oh, sure. Okay, so question of 5. Okay, so what is the meaning of class interval? As I told in the initial part.
It's the limit of the class.
Class interval. Okay. And what is the class mark of that class interval?
Average.
Average
of both the.
So what will be the average of 55 plus 60 divided by 2? I mean 55 and 60?
55.
Okay. It's a 55.
No, sir, 57.5.
Sorry,
So
57.
that is the answer.
Average of 55 and 60.
Yes.
Okay, sir.
Okay.
Sir,
Yes.
So
same activity, question number 3.
I told you initially, suppose I have class interval A, comma B. So class mark is the A plus B divided by 2. Okay.
Okay, sir.
And what about 6? So it's asking to which class does a student who got 65 marks? So for which class he will get 65 marks?
65 to 70.
65 to 70. Right?
Again, that average, no, sir. 65 to 70.
Hmm?
Sir, it's like average, sir. 65 to 70.
No. It is a question about to which class a student got the 65 marks. 65 marks belong. So 65, okay. So as you can see, this A comma B means this A is included, B is not included, right?
Yes, sir. It is excluded, sir. B is
excluded. So when I will get 65 marks, when this is right. So don't you can't do 60 comma 65 because in this interval
Yes,
65
sir. It is excluded. Little 64.9 something. Yes, sir. Yes, I understood, sir.
Sir, are you speaking? Hello.
Sir, but in 55, 60, 60 is not included.
Sir
It
has
is
left
asking
the
the class marks, not the include.
Hello. You cannot hear the voice.
Sir is not in meeting.
Sir left the meeting.
I guess this
Network issue
sir got
maybe.
disconnected or something.
Disconnected.
Sorry.
This is the first session for week 3, right? Statistics.
Yes.
Can anyone tell me how you guys got activity 3.1 question number 3's answer?
Hello.
Yes,
Hello.
sir.
Yeah, sorry, sir. Actually, my laptop was shut down by mistake. Okay, so let me just wait for a minute. Let me ask to make me co-host again. Okay, so yeah, uh, is there any other doubt?
3.2 question number 4.
So
Okay,
for
currently,
class interval, even if uh, the higher value is not included, we should just find the average.
yes. In case of class mark,
Yes, the class.
okay. 3.2 and question number?
4 and 5, sir.
Okay, 4 and 5. Okay, so uh, what is your doubt in case of 4? It's
Sir, I'm not sharing the screen.
yeah,
sir.
currently I'm not able to share my screen because I'm not co-host. Just wait for a minute. So I'm asking, what was your approach for that question? I mean, did you attempt any time or you just
Yes, I attempted and it was incorrect, sir.
okay? How what was your approach? Just tell us.
Sir, 1 minute, sir.
Sir, can I ask something?
Yes, please go ahead.
Sir, can we solve these questions like the ones with the data given with the help of Google spreadsheets?
Yeah, you can solve for the practice assignment, grade assignment, all, but during the examination, you will not, you
We'll
can't
have
do
to
because
will we get
yeah,
a calculator or not?
no, you can't. No, I mean, there will be one scientific calculator, TCS scientific calculator on your system, but you can't bring your, I mean, some physical calculator other than that. Okay. And don't worry about calculation and all. I don't think there will be too much calculation. But calculation will be
Sir,
like that.
my doubt was regarded to that only because in standard deviation and variance, sometimes
Yes.
the data is so long that it takes
Okay,
half an
okay.
hour to solve even one question.
So that's why I'm saying, see, I told you right, during the examination, you will not get that much calculation. There will be calculation. It's not like it's a total theory exam. But you can do on the scientific calculator as well. Okay. But in practice and graded, yeah, I agree. There is a lot of calculation involved, but it's good for you. It's practice. It's kind of practice for you guys. Okay.
Yes.
Okay. So yeah. So in the fourth question, I mean, how did you approach? I mean, it's a simple.
Sir, I just take the average of 425 plus 220 plus 62 like that.
No, why? Why? So there, so those are the
Because
only frequency.
they're taking average rating, sir.
Okay, average rating. But what is the, can you see the y-axis? Y-axis is the frequency, right? So those 78, 192, 425, 220, and 62 are the frequency. So if frequency is given to you, then how you can compute the mean? Summation of xi into fi divided by summation of fi, right?
Yes.
Okay. So your xi is here 1. For 1, your frequency is 78, right? Plus 2 into 192. Are you getting?
Yes, sir.
3
Fi
into
xi divided by fi xi. Yes.
summation fi xi divided by summation of fi, right? So it's not you have to just add the observations. So what you have done, you made a mistake. You have added the frequency and divided by 5. No.
Yes.
Okay. Those are the frequency. So frequency into xi. So xi is what? 1 into 78 plus 2 into 192 plus 3 into 425 plus
4 into
correct.
220. That's
Correct.
5 into 62.
Divide by
The total number. 5 plus no 1 plus 2 plus 3.
no,
That
no,
will
no,
know,
no,
sir.
no, 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 no. Divide by summation of fi. So fi is what? 78 plus 1.
Frequency.
Correct. So 78 plus
Okay,
190.
okay.
Yeah. Got it? Got the idea?
Yes, sir. Got it.
Okay. I think I have not co-host so far. Yes.
So can you please explain how can we find mean from 5-number summary?
Mean from 5-number summary, it depends on the data set. Is there any question?
Yes, sir. It was given in the practice assignment.
Which practice assignment?
Practice assignment 3.1, question number 2.
Okay. Let me ask to studio. Actually, I'm not able to share my screen so far. Okay. So I think in 3.1, you will get the different set of 5 questions once you refresh, right?
Yes,
Yes.
sir.
Okay, let me see whether I'm able to get it or not. Okay, so from 5-number summary, let me. Okay, so what is the minimum value?
So minimum value is 25.
Correct. And what is the maximum?
78.
78. Okay. And what are that middle observation? Q1, Q2, Q3?
35, 47, and 56.
Okay. So currently I'm not able to share my screen. Okay. So just listen to me carefully. So just draw a line. Okay.
Yes, sir.
So 25 is the minimum value. 78 is your maximum value, right? So what is the Q1? Q1 is what was the Q1? 35, right?
Yes,
so write down the 35. So after 25 there is 35, right?
Yes, sir.
So 25 is the minimum value and 35 is the your Q1, right?
Yes, sir.
So how many observation will be between 25 and 35?
24.
24 or 23? I'm asking between.
Between 23.
23, right? Because 25 is the minimum, 35 is the 25th value, right?
Yes, sir.
So there will be 23 observations.
Yes, sir.
Similarly, you can find the number of observations between 35 and 40. I mean, what were your 50th percentile?
47.
47, correct?
Yes, sir.
And similarly, 40 in between 47 and 50. What is 73? 56, right?
Yes, sir.
Correct. You will get the number of observations.
Yes, sir.
Now tell me. See, here you will not get the exact mean, but you will get the limit for the mean, right? I mean, lower limit. Okay, tell me. 25 is the minimum value, 35 is your 25th observation, correct?
Yes, sir.
So, what observation can be between 25 and 35? See, percentile is always in ascending order, right?
Yeah.
Minimum is 25. I'm saying 25th observation is 35, right?
Yes, sir.
So that means between 25 and 35, all the observation can be either 25, right?
25 to 35, na?
25 to 35, right? It can be 25, 25, 25, or 26, 26, something like that, or 35, right? Only then it will be in ascending order.
Yes.
Are you able to imagine?
Yeah, sir.
Okay, currently I'm not able to share my screen. That's why I'm explaining theoretically. So similarly, you can find the observation 35 to I think 47.
Yes, sir.
Okay. So now I think similarly up to maximum limit, right?
Yes, sir.
So now you can okay, tell me how will you proceed? So you have you can find the lower mean for the lower lower limit of the mean, like observation for the lower limit, right? 25, 25, 25, 25. Okay.
Yes, sir.
Then say minimum value. Okay. Now let me share my screen. So what I was saying. Okay, let me add a general. Actually, that due to disconnecting, I lost that page. Okay. Okay, so what was the minimum value was 25, right?
Yes, sir.
Q1 was 35.
Q2 47, Q3 50.
Q3 was
56.
okay, and what was the maximum value?
78.
Okay. Just tell me. Let me draw this line. Okay. Suppose this is the 25, which is the minimum value, right? This is the maximum value. Okay. Now I have Q1. So Q1, let's assume is somewhere this one, right? And suppose this is the Q2, and suppose this is the Q3. So this is the 35. This is the 47. This is the 56. Now tell me. This is the 25th percentile, right?
Yes,
that
sir.
means 25th observation. Similarly, this is 50th observation. This is 75th observation, right?
Yes, sir.
Now tell me, how many observations will be between these two?
23.
23, right? So 23 observations are there, right? So these 23 can be in between 25 to 35, right?
Yes, sir.
So it can be like 25, 25, 26, something, then 35, right? Or maximum value can be 35, 35, 35, right? Because it's in ascending order, right? It is clear? Now, same. Tell me values, how many observations from this to this?
23.
23 or 24? Because 35 is, we have to consider from 35 onwards, right?
Yes, sir. 24.
24 observation.
Yes, sir.
So what will be the lower limit? 35. And maximum observation can be 47, right?
But 35 was included in the first one.
No.
So
We
how
have
is it 24 observations?
We have excluded here, right? 23. Sorry. We are considering only 23 observations between minimum value to 25th observation, right?
Yes, sir.
Now from here, I will consider from this before this.
Okay.
Okay.
That's
So,
still 46.
so it's a 20. So total 25 observation between these, right? Now from here, I will consider the 47, and before 56 again 24 observation,
Yes, sir.
and lower limit will be.
Sir, can you repeat why it was 24 observation?
See, initially we are considering 23 because I'm seeing the observation between 25 and this 35, right?
Yes, sir.
From here, I will consider 35 onwards, okay? Because 35 is the 25th observation, okay?
Okay, sir.
Similarly, here. Now tell me, from here onwards, how many observations will be there? Tell me, what is the maximum number of observations? Is this in question?
Maximum was 78.
Maximum observation in number of observations.
99, sir.
99, right? So if it's 99, then how many observations will be from here onwards?
23.
23, right? So now tell me, this can be either 56, and between these observations can be 78, right? So far it is clear to all of you?
Not be included.
No. Suppose I'm writing here 56, 78, 78, 78, right? So it will be 78 still maximum value, right?
Yes, sir.
Okay.
Yes,
It is
sir.
clear? So far it is clear?
Yes, sir.
23 observations, sir. I don't understand.
Sorry?
Sorry? 23 observations, sir. The
How?
25 to 35. 23 observations, sir. I don't understand.
Okay, this
number
is
of
the first
observations.
observation.
Yes, sir.
This is the 25th observation.
Yes, sir.
So how many observations between these two?
23, sir.
That's all.
Okay, sir. Okay, sir.
Okay, so we can't find the exact mean, but we can find the limit for the mean, right? Limit for the mean. So mean means what is the mean? Summation of all the observations divided by number of observations, right?
Yes, sir.
So let me write the M1. M1 means mean for the lower observation. So mean means lower observation means we are considering the 25 minimum value plus, correct? So what I can write? 23 times 25, correct? If I'm adding 25, 25, 25, so this is the minimum value, first 25, right? This one.
But there can be different numbers like 26, 27.
That's why I'm saying I said we can find the lower limit and upper limit.
Okay, yes, sir.
Lower can be 25, right? So we are
Yes.
going to find the range, not exact value. I said, right, we can't find the exact because we don't know the exact observation, but yeah, we can say lower limit is this, maximum limit is this, right? Are you getting?
Yes.
That's why we are considering minimum value and maximum value, right? So mean, okay,
Yes, sir.
clear? I mean, are you getting the idea?
Yes, sir.
This is the minimum value, this is the maximum value, this will be the minimum value, this will be the maximum value. Now, so 25 is the minimum value plus 23 times 25 will be there if I'm considering the minimum, right?
Yes, sir.
Yes. Plus this 35.
Yes, sir.
Correct? Because this is the observation given to us, right? Plus 24 times 35 because we are considering only minimum value, right?
But sir, 35 we have included in the like 24 observation.
No, 35 is the one of the observation in this. Okay. Either way, I can write it as 25 times 35. I'm writing it separately so that you can get the idea. You can get the idea what is the exactly funda, right?
Okay.
See, here I can directly write down 24 times 25, including this 25. I'm writing separately because this is the minimum value, right?
Yes, sir.
So I want to separate the given value plus the values which we are considering in between. Okay. So this 25 is minimum. This 35 is the 25th percentile plus 24 times 35. So far, so good.
Yes, sir.
Plus this 47 plus, correct? What I can write down the next 24 times 47
Yes, sir.
plus 56 plus 23 times 56 divided by what?
99.
And plus 78 also. Because 78 is the last observation, right?
Yes, sir.
Divided by 99. So now you can compute the lower limit for
Yes,
the
sir.
mean. Now tell me about M2. M2 means maximum limit. So now see why I have separated, because now you will get why I have separated. Now 25 is the lower limit plus I have to consider the maximum, right? So maximum is 23 times 35, right?
Yes, sir.
Initially we have considered the lower possible value plus what will be the next value? 35 plus 24 times 47. Are you getting the idea?
Yes, sir. Yes, sir.
Plus 47 plus maximum limit for this. So 24 times 56. Right? So 24 times 56 plus this 56, this observation, yellow circle, right?
Sir.
56 plus 23 times 78 plus last observation, which is the 78 and divide by 90, divide by 99. I think after that, if you solve, you will get the answer.
Sir, I understood everything, but I still didn't understood why have we taken 24 observation in between like between.
Okay, see, we don't know exact observations, right?
Yes, sir.
We have just minimum value, 25th value, 50th value, 75th value, right?
Yes, sir.
So, okay, how you can compute the mean basically? Sum of all the observation divided by number of observation.
Yes, sir.
But I don't know how many, I mean, what are the observation in between, correct?
Yes, sir.
But I know there are 23 observations between 25 and 35. Okay, means I
Yes.
know there are, okay, so this is the first value, minimum
Yes.
value, this is the 25th value, right?
Yes,
So
sir.
I know this is the 23 observations will be between these two, right?
Yes.
Even though I don't know the exact observation, but minimum can be 25, maximum can be 35.
Yes, sir.
Correct?
Yes,
Suppose
sir.
I asked to compute the mean of these data sets. So you can simply compute the mean of these data set, right? 25 plus 23 times 25 plus 35 divided by 25. Correct?
Yes.
This is the lower limit you will get. I mean, you will get a lower limit can be this one. Okay. And what will be the maximum limit for this? 25, this
Plus
value plus 23 times maximum, right? 35 plus 35 divided by 20.
Yes, sir.
The same thing I have done for those remaining parts. Okay.
Sir, but I didn't understand it. Is that why is there 24 observations?
Okay, you did not. Okay, tell me. Here I consider the between these two, right? But from here I will include the 35, right? From 30, I mean from this 25th
No,
and before this.
In the previous one.
Sorry?
35 isn't included in the previous one.
Okay, if you will include, then how it will be 23?
So,
see, this 35 is the 25th value.
Yes, sir.
Okay, this is the first value. Okay.
Okay.
Then
There
what
total
is
like before 35 there is the 24th value, but we are taking
what I'm saying between 23 and this one. Are you getting?
How, sir?
See.
Yep.
This is the first value, right?
Yes.
This is the 25th value.
Yes.
How many observations are between 23 and 35 or 25 and 35?
23.
Okay.
Yes.
I said in between.
Yes, in between. Yeah.
Correct? Now from here to before this.
If we are including 35, then 24.
Correct? Same
Yes.
this one. Same this one. Because 78 is the 99th value, right?
Yes, sir.
Because maximum number is number of
9.
observation 99.
Yes, sir.
Okay. So it's a something, say percentile. Basically 35 is the 25th percentile. Okay.
Okay.
Yeah. Clear to all of you?
So,
yes.
And in the same question, there was an like it each
Sir,
person.
Sir, I have another question. Actually, question 3.1 question.
One by one.
Practice assignment only, that second question.
Which practice assignment?
3.1.
I think for 3.1 question may be different actually.
Yes, sir. There was this question with like mean of observations x1 to xn is 15. Mean of x1 to x2n is 45, and the mean of observation x1 to x3n is 34. So what will be the mean of all those?
Okay. Let me refresh so that may get the question.
Sir, activity.
Let me see whether it's there or not. Okay, so can you tell me the question? I will give you an idea. Okay.
Actually, 3.1 question 2.
3.1 question 2.
No, sir.
Yes,
Okay, one
sir.
second, one second. Let see while one thing I can say, see, if we are discussing, let's say, suppose someone asks in activity, right? So you can immediately ask, yeah, sir, I have doubt in the same activity and all, okay? Because, okay, so what is your doubt? Okay, so after this, I will come to that practice question. What is your doubt in this question?
Second question, sir.
What is doubt? Second was, do you want whole solution or did you attempt any time?
Yes, sir. Whole solution is unable to understand the question.
Okay, any one of you wants to explain to her?
Sir, is the questions being changed, sir?
No, it's activity.
No, I mean my questions are different in AQ activity 3.1.
No, for AQ it's same. I don't think it's a different. Should be
Acha,
different.
okay, AQ. PMA it's getting changed.
Yeah,
sir.
PA
Practice.
3.1. Yeah, for practice 3.1 it's okay. Yeah. So question is, in a shopping mall, a customer will get a scratch coupon after shopping for over a certain amount, right? The customer will get cashback between 1 to 100 rupees, and Madhu is a regular customer to the shopping mall. The cashback she received over a period of 6 months is given to you. Okay. So how much percentage of her total time did she receive the cashback worth of 40 to 60, right? So how will you proceed? Tell me. Anyone wants to explain?
Sir, it is like we need to find how much time we have got the 40 in between 40 to 60.
That is
Means
6, right? That is 6.
yes, sir. 6
6.
upon the total frequency, and we
Correct.
need to find the percentage. So
That's
that is into
multiplied by
100.
100. Correct.
Yes.
So 6 divided by total is 15 and 35, right?
Yes, sir.
So 6 divided by 35 into 100, what it will be?
17.15.
17.14, right? So as you can see from the here itself, you can check the answer actually.
You have to
So
calculate relative frequencies.
sorry?
You have to calculate the relative frequencies.
Yeah, relative frequency. It's a simply asked, did she receive the cashback? How much percentage of the total time? What is the total time actually? If you add all the frequency, you will get the total, correct?
Yes.
For that particular class, which is 40 to 60, right? So 6 divided by total into 100. Okay?
Yes, sir.
Got the idea? Yeah. So someone asked that question. Can you tell me, because I'm not getting that question in my.
Question which you previously solved. What is the question number?
I don't know actually. She asked from practice assignment 3.1, but
Question number 2, but
actually, you will get the different set of questions when you refresh.
if the mean of observations, there is like observations given x1 to x.
One second. I'm not a robot. Okay, tell me.
If the mean is given.
Okay, mean of what?
X1 to xn.
Okay.
Is 15.
Okay.
And mean for x1 to x2, x3 to x2n.
X2.
No, x1.
Okay. X1, X2 up to X2n, right?
Yes.
What is the mean?
45.
Okay. And?
Mean of x1.
Okay.
To x3n is 34.
X3n is 34. Okay.
Yes. So what will be the mean of 2xn plus 1?
2xn plus 1, right? This n plus 1, okay, in subscript it will be, I think.
Yes, in subscript. So then it is 2xn plus 2. Then 2xn plus 3 to 2x2n.
X2n, okay.
Then comma 3x2n plus 1 in subscript.
Okay.
And then 3x2n plus 2.
Okay.
Till
Then up to
3x3.
3x3n, right?
Yes.
Okay, so basically we have to find out the, okay. So
Sir, which question is this, sir? Which
again, I'm saying I don't know. Actually, see, it's from practice 3.1, but I'm not getting the question because if you refresh, you will get a
Okay.
different set of questions. Okay.
Uh,
Okay. So let's write down the things first. Let's see what will be the what are the required things. Okay. If I want to find out the mean of these things, so that means what? Mean, how we can find the mean? 2x plus 2xn plus 1, 2xn plus 2, plus so on, 2x to n, correct?
Yes.
Plus 3x 2n plus 1, plus so on, 3x 3. How many observations will be there?
2n plus 3n.
2n plus 3n or 2n observations?
2n of them.
2n observations, right? Why 2n? Because if you see from here to here, n observations is there, correct? And from here to here, n observation is there, right?
I did not get this. How?
Okay. Tell me. There is one trick in mathematics you can say. Suppose I'm saying 1, 2, 3, 4, 41, 31. How many observations this is?
6.
6. Okay. So, okay. How will you get 6? You have counted simply, right?
Yes.
So there is one trick you can say. What you do? What is the maximum number? Not 31. If you count, it's a 6.
6.
And what is the first one? Is the first, right?
Yes.
So if it's 5, but you have to add 1, you will get the 6. Okay, don't worry. I think you will get confusion. Now, okay, tell me. You have n plus 1, n plus 2, same as n plus n. So n observations is there.
Okay, sir.
Okay, and from here 2n plus 1, 2n plus 2 up to 2n plus n, right? Again n observations. So these n plus these n, total 6 2n observations, right?
Okay, sir.
So this is something how I can find out the mean, right? This is the funda of the mean, right? Sum of all the observations divided. No. So what is the next step? If you take the common 2, so it's a x n plus 1 plus x n plus 2 plus so on x 2n, right?
Yes, sir.
Plus 3 is common. X 2n plus 1
Until
plus x 2n plus 2 till x 3n, right?
Yes, sir.
Divide by 2n.
2n.
So what we have to find by the question, you can see we have to find the value of this quantity and this quantity, right?
Yes,
From the
sir.
given things, right? So things are given a mean of x2, x1 to xn is 15, mean of x1 to x2n is 45. Okay.
Yes, sir.
And x1 to x3n 34. Okay, let's proceed. So we have to find out the summation of these xn plus 1 to x2. So mean of x1 to xn is 15, right?
Yes.
So that means what? Summation of xi divided by n is 15.
Yes, sir.
Correct? So that means what I can say, summation I is equal to 1 to n, xi is what? 15. Correct? Not 15 times n.
Yes.
This is the, make it as equation number 1, right? And next is x1 to xn, x1 to x2n, mean of these others is 45, right?
Yes.
So mean of xi, right? And I goes to 1 to 2n, right?
Yes, sir.
So mean is 45. So observation is 2n, right?
Yes, sir. So it is
So
90.
from here, yeah. So why I'm writing like this? Because I have to find out the summation value, right? So it will be 90 times n.
Yes, sir.
Right? Since now, can you see, if you observe carefully, can I split this one? Summation I is equal to 1 to n xi plus summation I is equal to n plus 1 to 2n xi, right? Can I write down or not?
Yes, sir.
I can write, right? Right? Hello?
So how I is equal to n plus 1?
I is equal to 1 to n.
Yes.
See, initially is I is equal to 1 to 2n. I have split it. First I'm adding 1 to n and n plus 1 to 2n. See, what is the meaning of this one? This means
Okay, so
x1,
after 1
x2,
like
yes,
the next.
xn
Okay.
plus 1 and so on,
Yes.
x2n, right?
Got it. Got
I
it.
have split it because I need this summation.
Got
Correct?
it. Yes.
So from here, what I can do, summation I is equal to n plus 1 to 2n xi,
Tn minus
90n minus,
75
and for this, we have 15n. Correct?
Yes.
So I got 75n, right?
Yes, sir.
So we got the value of this quantity, right?
Yes, sir.
We have to find out the value of this quantity now.
Same
So
way
for
this will be this.
correct. And we know summation mean of xi 3 and what was the mean? 37?
34.
34. So this is 3n observation is 34, right?
So it will be 1.
So summation I is equal to 1 to 3n xi, it will be 34 times 3n. So it will be what? 102. Yeah, 102n, right? And these things I can split. Correct?
Yeah.
So you can split because I need from 2n plus 1 to 3n. So what I can do, I can split like 1 to 2n xi plus summation I is equal to 2n plus 1 to 3n xi equal to 102n, right?
So it will be 102 and
So value of this one, this is what? 90n.
Oh yeah, 90.
So summation I is equal to 2n plus 1 to 3n xi is equal to 102n minus 90n. That means what? 12n.
12.
Yeah. So we got the value of this one also as 12n, right? So
Yes.
mean will be 2 times 75 times n
Plus 3 into
3 into 12 times n divided by n. So if you see, I will get 150 times n plus 30n divided by n. So we'll get
186.
186 n divided by n. So n will get cancelled.
2n.
Sorry, yeah, 2n. Sorry. Great. So it will be n will get cancelled out. So we'll get
93.
Is this answer?
Let me check just 1 minute.
Yeah, you can check. Okay, is there anything else or we can wind up because tomorrow is also session. So
Sir, I have one more question in 3.5.
So can these types of question also come in qualify? This lengthy
no, not that much calculation. Not that much.
Yes, sir, the answer is correct.
Answer is correct. Okay. Okay, so yeah. Okay, so is there anything else or
Sir,
if
in
not,
3.1.
Yes, sir. 3.3 question number 4 and 6.
3 point?
Sir, in simple standard deviation.
One by one. 3 point with 3.3 or
3.3 question number 6 and 8, sir.
3.5 question number 4.
3.3 question number 6 and
8, sir. 6 and 8, sir.
okay, you will tell me the answer. I have explained the same concept. You guys will tell me the answer. I'm not going to tell the answer for that question. It's a simple property which we have discussed. Okay, so median of your observation is given to you 45, right?
Yes, sir.
Okay, and what is the new data set? 3x1 plus 1
times x1 plus 1, sir.
Correct. That means what we are doing, we are multiplying by 3. Okay, so if you multiply by a constant, then what will be your new median?
Sir, old median into that constant, sir.
So that means 3 into 45.
Yes, sir. 3 into 45 plus 1, sir.
That's the answer.
Okay.
So read the question carefully. Okay. That's
Also,
why.
question number
Sorry?
5. Can you just solve question 5 and 3.3?
What is the doubt? Median?
Sir, this one is like normal procedure only, sir. We're right 51, 52, 54.
Yes.
Okay, sir.
It's a not, see, you can see key is written here, right? I mean, here it mentions 6 in the stem and leaf in the 4. That means 64. That means your observation are 51, 52, 54, 55, 57, then 64, 67, 68, 60. So normally count the number of observation and you will get the, and accordingly, if any odd and or any given, accordingly you can apply your formula.
Yes.
So same for the 8. I think 8 is the mod of the marks of which teacher awarded for. Yeah, okay. So I think 70 is the answer, right?
Yes, sir.
Why 70 will be the answer?
66 plus 4.
For additional mark to each
That's all.
student.
Yeah, that's all. So that's why
Then
we have
it will be
explained.
70 something.
That's why we have explained all the concept, right?
Yes, sir. Yes, sir.
So be
Yes,
clear
understood.
with that. Okay. So
Sir, can-
let's.
One question, 3.5, question number 4.
Okay. After that, we'll wind up the session. Okay. So what is the question? I think you joined late. This question number 4, someone asked in the session itself.
Okay, sir.
Okay. So okay. So okay. Let me tell you. What is the first step to find out the percentile? Hello.
Yes, sir.
What is the first step to find out the percentile? You have to arrange the data set, right?
Yes, sir.
Okay. So suppose you have arranged. So 15 will be first observation, then 25, then no, not 25, 23, 25 and onwards, right?
Yes, sir.
So 9th percentile. So what is the value of n? N is how many observations you have?
9.
9. What is the value of p?
What is the value of?
P.
P is P is equal to 9. So 0.09.
0.09. So I have to compute the n into p. So n is 9, p is 0.09. So 9 into 0.09 means 0.81.
Yes.
So 0.81. So what will be the next smallest integer? Is the first, right?
Yes, sir.
So first observation is 15. So 15 will be the answer. Okay.
Okay, sir.
Sir, in sample variance, we have standard deviation, sample standard deviation we have to do and divide by n minus 1 or n.
Yeah, n minus 1. In case of
Okay.
sample variance, it's a 1 upon n minus. Okay. In case
And
of population.
how to find outliers? You explained or
Outliers.
Yeah, so just for the outliers, just rewatch this. Okay. We have discussed the formula of outliers and how you can I can find out the whether outliers are there in my data set or okay.
There are outliers, the abnormal values.
Sorry.
There are outliers, the abnormal values.
No, outlier is something which is far from your normal observation. Okay, which is something extreme data. Okay. Yeah, just okay, and you can see the box plot also. Okay, that like minimum point, right, and maximum point. So below the minimum point, outliers is there. Above the maximum point, outliers is there, right? So
Sir,
outliers
you
is
explained
something.
in this video na before. I will see on YouTube.
Box plot, are you saying that below the quarter 1 and the quarter 3?
No, I think you guys are not listening me carefully. I have so while okay, so this is the box plot. Okay.
Yes,
Actually, box plot is free from outliers. So this is the minimum value box plot. This is the maximum value. This is the Q1. This is the Q3 and Q1, Q2 will be in between Q3 and Q1 as per your data set. Okay.
Yes. Yes.
So outlier, suppose there is something observation, so it will consider as outlier. Okay.
But sir, if the box plot is not given, then
yeah, sir.
I'm just trying to explain what is the outliers. Okay, box plot is not given if you are given the data set. So simply there is formula to compute the outlier. Outlier should be less than Q1 minus 1.5 times of IQR, or you can check the Q3 plus 1.5 times of IQR. I mean, there should be one observation. If there is any observation which is less than this quantity, that will consider as outlier. And there is any observation in your data set which is greater than this quantity, that will consider as the outlier. Okay.
there was
this
this
is
formula given. I don't think that it was in the lecture.
Yes, sir.
I think if it's not in lecture, then it has been covered in tutorial. Okay.
Okay.
That's why I told you. Okay? Or else what you can do, you can just rewatch the lecture video. I have explained, and I also took the one data set and I had discussed the whether outlier is there or not. Okay.
Okay.
Okay, then thanks. You can ask the remaining question, I think.
Thank you, sir.
Hope you got the concept of week 3 and all.
Sir, I have a doubt.
Where?
Sir, in the assignment.
In which?
3.1. Recently, I have asked a question about 5-number summary.
Uh-huh.
Sir, in that, there was an option that 80th percentile valued 78.
80th percentile value is?
78.
Okay, you tell me whether it should be correct or not.
Sir, according to me, it shouldn't be correct.
Why?
Because 78 is the maximum value, so that should be 100th percentile.
That should be 100%. Okay, while I was taking the okay, tell me. N is 99.
Yes, sir.
Right? What is the P?
P for which?
0.8.
Yes, sir. 0.8.
If you want to, okay, just that's why I told you, just listen to concept carefully and then try to apply. Okay, N is your 99. Okay, P is 0.8.
Yes,
99 into 0.8 means what? How much it will be?
19.
Just compute 99 into 0.8.
79.2.
79.2. 79.2 means 80th observation.
Yes, sir. 80th value.
Now tell me, after 56, 75th percentile was 56, right?
Yes, sir.
So after 56, all the observations can be 56, all the observations can be 78, right?
Yes, sir.
Are you
Yes, sir.
getting? If all the observations are 78, so 80th observation can be 78 or not?
Yes, sir.
Can be. Okay.
Then it मतलब like वहाँ पे ऐसा होना चाहिए 80th percentile value can be.
Yeah.
So 80th percentile value is 78.
Is 78? That's option. Okay. If you read the question carefully, then in the question, I think it will be question statement will be like could be or can be will be there. Can you read the question?
Yes, sir. Could be true.
Yeah. So read the question carefully. All the things are given clearly. Okay.
Yes, sir. Thank you.
Okay. Thanks, guys. Then okay. Hope you got the concept. Rest of the doubts will discuss tomorrow. Okay.
Thank you, sir.
Okay. Thanks. Bye, everyone. Good night.
Thank you, sir. Thank you so much.
Thank you, sir.
The session got over.
Yes.
Okay, thank you.